next, so we have to represent what is meant by Huffman coding, what is run length coding, what is meant by bit plan coding, what is meant by LZW coding. So in Huffman coding, we have represent the probability based variable length and minimizing the average code length. So we have to find the probability based variable length. So we have to identify the probability with respect to range of 0 to 1. Though number of repetitive values, nothing but if the value is 0.2, 0.2, 0.2, 0.1, 0.3, 0.4 means we have to group in the 0.2 value as a one of the values and 0.3, 0.4 and 0.1 is considered as a another of the probability. So based on this probability identification, we have to generate the transmission code, and also we have to find the minimized average code length by using the Huffman coding technique. Another method is run length coding. So here the run length coding is mainly used in the pixel representation. In the pixel and intensity identification is mostly effective for the binary images, because here the run length coding we have to find the consecutive data transmission through the pixel values, nothing but consolidated consecutive identical value into the single count. So nothing but if the transmission data is 111, 00, 11 means it is considered as a 1, 3, 0, 2 and 1, 2. So the 1 is the binary value which has to be transmitted. 3 is a number of repetitive values. So nothing but 1 is repetitive in 3 times. Here the 0 is repetitive with 2 times and 1 is repetitive with 2 times. So this concept is applied in the run length coding. Also we have to apply it in the matrix representation in the form of spatial representation. Nothing but in horizontal and vertical run length coding. So even that run length coding, we have to identify the compression ratio. If the compression ratio is above one value, if the below one value means it is a inefficient compression method, we have to represent. If the method is a efficient one means the value is above the value of 1. So another one method is a bit plan coding. So the bit plan coding is that decomposes the multi-level images into binary planes to expose the higher order structural redundancy. So we have to represent, for an example, we have to identify the values with 0 to 8 bit representation. So 0 to 7 bit representation. If the 8th order values are represented in a single plane, 7th order representations are stored in a 7th plane. If 0th order representation, nothing but in the binary values are stored in the 0th plane. So based on the plan, we have to decompose it into multi-level, and the binary plan is exposed to higher order structural redundancy. We have identified the redundancy values and removed by using this bit plan coding. So here nothing but we have to decompose the pixel values with respect to multi-level images into binary planes. So next one is a LZW technique. So this technique is a fast and dictionary based dynamic substring requiring with no period probability knowledge. So for an example, here we have to identify the sequence of A, B, C, D up to different strings. For an example, A, B, C. So in dictionary we have to identify it with respect to A is considered as a C. After that, the subsequence, based on the subsequence values, we have to get the data from the dictionary. From the dictionary, we have to modify the value. So this is the LZW decoded value, maybe is XYZ. So in reconstruction or decompression technique, we have to apply the LZW decoding technique for reconstructing the transmitted data with the efficient compression or efficient encoding technique. So also we have to represent the lossy compression. So we discussed the Huffman RLE run length coding. Another one is a bit plan coding. So these are the techniques we have used for LZW. These are for the lossless compression technique. So the block truncation coding is nothing but it is comes under the lossy compression technique. So this is nothing but the step block truncation encoding, which is divide the grayscale image into non-overlapping 4x4 pixel blocks. So nothing but it will be divided into blocks. Then the value is given to the two-level quantizer independently with the each blocks. After that, the quantizer signal is given to determine the mean and standard deviation. So nothing but it have to reconstruction with respect to the local statistics to the maintain the original brightness and the contrast. So this is comes under the block truncation coding method. Block truncation coding method. So after that, so we have to apply some compression technique. So this is the example for the total database. So this is comes under the total database. Then it is given to the compression kernel. So this compression kernel based on the lossy or lossless compression technique. Then the signal is traveled to the machine learning pipeline. In advanced technique, we have given the data to the machine learning, or either we have to transmitting the data through the transmission protocols. With either that wired medium, wireless, or through 2G, 5G, or any high frequency data transmissions, we have able to transmitting the compressed data, or the compressed data will be given to the any other decision making techniques. So this is the overall explanation for the image compression. So after that, after the image compression technique, we have to discuss about the applications of digital image processing with satellite and facial recognition techniques. So this is what is the need? What is the need of compression in or image transmission in the satellite images? Is the sensor is continuously changes, capturing the massive high dimensional data set of the Earth surface. So we have to transmitting the data, or either it capable to store the data in the storage devices. It is more complicated. So we have to compression is a major technique which is used in the satellite image transmission and storage methods. So here the compression minimizes the file size for efficient long-term archival while drastically reducing the bandwidth required for the real-time transmission to terrestrial stations and without degrading the necessary analytical quality. So this is the main thing. So we have to compress the data without affecting the information which will be used for the analysis in the base station or research area. So we have to use the compression technique. It is used in the satellite image processing. So another one is the massive applications is here authentication. So now here this is one of the applications here, facial recognition. So nothing but we have in the database we have the more, we have stored the more thousands of faces will be stored in your data. We have identified the which of the human will be identified or authentication through the facial recognition system. Nothing but authentication system. So this is the steps we have to use. We have to compress the data, whatever we have to captured through the camera, and it will be stored and it will given to the feature extractions. Here we have to identify the landmarks, different pits, different surface and points in the faces. We have to identify the feature extraction. After that it is given to the machine learning classification. So we have to classify the shapes and features or we have to segregate in the total input. It will be identified by the machine learning. Finally it will be give the identification output. So if the authentic person will be identified by the facial recognition system. If the unauthorized persons have to be accessed, means if they identify and give the output as a unauthenticated, the database, the person or the person database will be not stored like that. So these are the overview of the unit 5 digital image compression and applications of image processing. So this is the overall representations. So this is the during the acquisition system, we have to gather the raw data acquisition and identification of the redundancies, and it will be compression using lossy, either lossless compression, and the data will be stored and transmission through the network. Finally, to reconstruct the image, and we have to given for the application processing for analysis purpose. So these are all the different stages for the image acquisition and processing technique. So after that, we have represent the, when the objective is to reducing the physical data in the informations, and also we have to apply the systematically exploit the coding, interpixel and psychovisual redundancies via mathematical algorithms. Finally, we have to find the impact with respect to enable the global scale computational applications by overcoming hardware limits in storage and bandwidth. So ultimately, the image compression is used for the storage the data. The data will be able to transmitted with respect to transmission to the channel, and also we have to use it for the computational complexity. So these are the different methods for different usages. We have go for the image compression technique.